let's now go on to rainfall. Okay, in terms of rainfall, it's the same, uniformly high. Okay, so temperature uniformly high, rainfall is also uniformly high rainfall. There are no dry months and no seasonal variation. If you look at this climograph given, in terms of the precipitation bars, you can see that there's rainfall in every month, and the amount of rain received every month is quite high. Okay, so this is a typical of the AF climate. And this has to do with the influence of the ITCZ, which we will look at shortly. Okay, then you also need to know the figures, right? So you need to know the amount of rainfall that is received. So in AF climates, generally it receives around 1,500 mm to 2,500 mm of rainfall. Singapore will receive about 2,000 over mm. So Singapore is also part of the AF climate, right? And the yearly rainfall in AF climate is exceeded only by one other type of climate, which is the monsoon climate, which we will learn next week in school. Okay, and then in this example of Brazil, in this area, the annual precipitation is 290 cm, which is 2,900 mm. So it's really high as well. Okay, so this is considered high. Okay, so why does AF climates have high rainfall? This has to do with the position of the ITCZ. Okay, and the highest rainfall usually also occurs in March and September. Not always, but it tends to occur in March and September, especially if the AF climate is at the equator. Right? Why? Because we know that in March and September, the sun is overhead at the equator, and therefore ITCZ will be at the equator. Okay, and this it will then bring heavy rainfall. So for areas that are at the equator, usually the heaviest rainfall would occur in March and September when the ITCZ is at the equator. Okay, so once again, you can see the importance of the ITCZ in influencing rainfall in AF. Alright, so let's look into it in more detail. So for AF climate, they have uniformly high rainfall throughout the year because for most of the year, if not for all of the year, it is under the influence of the Hadley cell, and more specifically, the influence of the ITCZ. Okay, so high rainfall throughout the year because for AF climates, they are under the influence of the Hadley cell throughout the year. I mean, when we look at the Hadley cell, mainly we are looking at the influence of the ITCZ, which brings rainfall in these to the AF climatic zones. Okay, so we look at Hadley cell, actually what we mean is the ITCZ in the case of AF climates. Of course, local factors like altitude, coastal locations, all these will also affect rainfall, okay, but these are more localized factors. So in this case, like we said in this lecture, we want to look at the overall rainfall pattern. So to explain why in general AF climates have uniformly high rainfall, the main reason is because of the Hadley cell, and more specifically because AF climates are usually throughout the year under the influence of the ITCZ. Okay, so as I just mentioned, AF climate is almost always under the influence of the ITCZ, and we know that at the ITCZ there's both convective and convergent uplift. So because there's two mechanisms of uplift, there's a lot of rising air in the area. So if there's a lot of rising air in the area, it leads to cooling, condensation, eventually the formation of clouds and heavy rainfall. So the ITCZ is a belt of persistent cloud cover and heavy rainfall. So if you link back to a diurnal temperature range just now, you realize once again that with a persistent cloud cover, the diurnal temperature range would then be moderated. Okay, at the same time, ITCZ also brings rainfall. So this is why the AF climate usually experiences high rainfall throughout the year, as long as it is under the influence of the ITCZ. Some of you may be wondering, the ITCZ shifts, right? So yeah, we know that it migrates in response to the position of the overhead sun, right? But because these AF climates are located close to the equator, it means that despite the migration of the ITCZ, it is still usually under the influence of the ITCZ. I will show you this in a demonstration shortly. Okay, so now I'll show you the demonstration. We'll look at the case of Singapore. So Singapore is an example of an AF climate in Singapore, and we receive about 2,400 mm of rain in a year. And you can see that rainfall is high throughout the year. There are no dry months, right? Uniformly high rainfall throughout the year. And this has to do with the location of Singapore. So Singapore is located at 1 degrees north, so it's very, very close to the equator. And therefore, throughout the year, Singapore is under the influence of the ITCZ. So what I'll do now is I will use this simple model to help you to visualize the influence of the Hadley cell on AF climates such as Singapore. But I want to just say that this is just a model, right? So this is just a model. It's not perfect, but it's meant to help you visualize what is happening. Okay, so to help you visualize, this is Singapore. Obviously, Singapore is not so big, right? But I pasted a star here, so it's easier for you to see Singapore. Okay, so as I said, it's just for illustration purposes. So it's not 100% accurate and to scale. Okay, but it's just to help you understand how it works. And then this is a blue piece of plastic, right? This represents the ITCZ. So it represents the rain belt. Okay, so it represents the rain belt of the ITCZ. And then the red color represents the dry conditions under the STH. Okay, so let's see what happens when the ITCZ shifts throughout the year in response to the position of the overhead sun, and let's see how it affects rainfall in Singapore, which is this star over here. So just try to focus on the star over here, which represents Singapore. Okay, so in March, we know ITCZ is at the equator. Right, so in March, ITCZ is at the equator, and then it slowly shifts up in June to the northern hemisphere. But you see that Singapore is still under the influence of the ITCZ. Okay, then it shifts back to the equator in September, and it shifts down to the southern hemisphere in December. So if you look, you can see that no matter how the ITCZ shifts, right, throughout the year, Singapore is mostly still under the influence of the ITCZ, and thus it has uniformly high rainfall. Okay, I'll play it again just for you to see. So March at the equator, and then it shifts up in June, but Singapore still receives rainfall from the ITCZ. The ITCZ shifts back to equator in September, and it shifts down to the southern hemisphere in December. So no matter how the ITCZ shifts, Singapore is mostly still under the influence of the ITCZ, and thus it still receives rainfall throughout the year. Okay, so this is the reason for high rainfall in AF climates in general. So just to sum up, you may want to take this down. Okay, you can pause the video and copy. So the main reason for AF climate is latitude. So we know that AF climates are located near the equator, within 5 to 10 degrees north and south of the equator. So because of this low latitude location, there is high and uniform temperature due to high angle incidence, thinner layer of atmospheric obstruction, and minimal seasonal variations. At the same time, there's also high and uniform rainfall due to the persistent influence of the ITCZ. So even if the ITCZ migrates, this AF climates being close to the equator would still be under the influence of the ITCZ throughout the year, as I've shown you in the demonstration just now. Okay, so this is it for AF climates. So you may want to pause to take down this diagram.